Okay, now that we've covered the history on graph theory, let's go over some basic vocabulary so that we can communicate about how we're going to use graphs to solve some problems. Graphs are like a tree, except a node can have more than one parent. In mathematics, trees are a particular type of graph, not generally called out to be special. In CS, trees are so useful we treat them as their own topic with their own vocabulary. In graphs, we call a node a vertex. It's what Euler came up with in 1736 to call these things, so it predates computer science. The plural of vertex is vertices. The connections between two vertices are called edges. Normally, we build links in trees as convenience to the algorithm. If we want to find something, we do certain things or whatever. But in graphs, we use edges to model our problems. So the shape of the graph, where we put the links, how many links we have, where they relate to, tends to be a model of our problem, not a model of what's easy for our algorithm to do. Here's an example graph. Each circle is a vertex. It's like a node in a tree. Each line is an edge. The length of an edge is not important. If we don't specify, then edges are bidirectional. The letters are labels. They allow us to identify a vertex. For instance, I have a vertex called A and a vertex called B, and so on. Adjacency. If two vertexes are connected by a single edge, then they are adjacent. For example, A is adjacent to D, A is also adjacent to B, but A is not adjacent to E, and A is not adjacent to C. Paths. A path is a sequence of edges. For example, ABE is a path from A to E, as is ADE. There are two paths. There are two ways to get from A to E. If you recall, with a tree, there's only one way to get from a node to the root node. There's only one path. But in trees or in graphs, there can be any number of routes, of paths. In a connected graph, which this is, there's at least one path from every vertex to every other vertex. This graph is non-directed because all of its edges are bidirectional. We can also have one-way edges, which become a directed graph. We'll discuss that in a few talks. This is an unweighted graph. All the edges are the same value or weight.